At Churchill Park, one animal that lives in this area is a bat. And some bats are having a hard time surviving because they're losing their homes, and that's kind of a big problem. So environmental engineers and scientists, like a wildlife ecologist, might look at some of those problems and then try to figure out solutions. One of those solutions is something that you can see right behind me. Here at Churchill Park, they've put in a couple bat boxes, and those bat boxes are just a nice little home for them to sleep in. Another problem that we experience at any wildlife area, including Churchill Park, is light pollution. So a lot of animals are awake at night, and we call that nocturnal. Okay, so you'll see the moon, and that's usually what gives you some light. But sometimes houses and even a couple lights on the school have some light pollution because that light comes into the darkness and comes across the parking lot and into the woods. And that kind of interrupts some of the stuff that nocturnal animals do because it makes it a little bit harder because their eyes adapted and adjusted to it being so dark. So when they have extra light, it interrupts with some of the stuff that they do, including eating. So we have to be careful about what kind of light we have next to wild spaces. And sometimes we have to put on protectors, like on top of the lights behind me on the school, the ones that are attached. They have things on the top that point the light down so it doesn't go towards the woods as much. What would you do to solve a light pollution problem? While the area behind me may look like a grassland, it's actually more of a wetland. So while all of those plants are in there, see that bridge? That bridge had to be created to help us solve a problem of how do we walk through an area without disturbing the natural wetland that's there and disturbing animals' homes and really not sinking in to the mud that's there. So that's kind of what an engineer does. We figure out what the problem is. So we had a natural area that we wanted people to explore here at Churchill Park. And so one of the ways that we did that was by creating a bridge. And we have to get people on board that can design that bridge, that can create that bridge. So there's a lot of steps in the engineering design process involved in just something as simple as making a bridge to walk just such a short distance. One of the problems that Churchill Park has had to think about is what do they make the path out of? Paths can be made out of concrete or cement or a crushed rock that we call limestone, or even wood chips, and some paths you've seen might be dirt. When we think about paths that people have to walk on all the time, what would be a good reason for having a certain material? I want you to make a good scientific prediction on what would be a good solid material that you want to use for the path. Use your I think because. Behind me, you can see a liquid that we call water. And with water, it's actually a very strong force. So when water is running along, it can actually pick up solids along a creek bank like the one behind me. And when it does that, we call that erosion. So when water comes down the stream, picks up little pieces of solids and brings them down the stream, and it wears away at the banks and makes it like either bigger or smaller depending on what the problem is. We want to make sure that it's not doing that too much and destroying like the plants that live there, might be destroying things that people at the Park District have created. So it's important to keep track of erosion. Now, an important thing that Miss Renee Frigo did over at the Park District is she installed erosion pins. And erosion pins are a piece of metal that she stuck in the side. So she was a problem solver. She was an engineer. And what she does is she measures every once in a while how much erosion has taken place. So she measures from the end to where the edge of the stream is. And when she does that, if the distance gets bigger, like in inches, if it goes from like 1 inch to 4 inches, that's a big difference. And that means a lot of erosion is happening. And we have to figure out ways maybe to slow that down so it doesn't destroy anything important.